And once again, what we are starting with? We are starting with my irritation and with my scandal, because it's already 20 minutes after we supposed it to start, and only 4 of you, no, now 5 of you, Godwin has disappeared in class 20 minutes after class supposed to be started, as I said. And my congratulations to Alena. She was the first day, even 2 minutes before class, and she greeted the previous group, Ukrainian people. If you came on time, guys, you would have opportunity also to make acquaintance. Look, what you see right now, what I'm showing you in the screen. You already know that when it's possible, I'm sending you video files in order you may repeat the class even in video format. You have a lot of video files here, video classes exactly, which immediately your group classes, or wherever I had previous group records, I also sending to you. Some of them you have how it's called, links in them immediately in Mentor. Some of them you have in Telegram, and for your convenience, maybe it's not convenient for you for some reason to watch in Telegram or to see to download the whole file. I'm trying to show you it in YouTube also, but they are not visible in my official channel. No, I mean in open way, they are not visible. If we did. If you open my channel, the only thing that you will see, it's only about, no, I mean, open things, no? You will see only something about cats and nature, and maybe these Easter bells, not more. But really, I have there already some dozens of classes, of videos, and so on, which immediately related to your education. I don't know how to show it completely. Some of them completely hidden. You see only something that is available by link, as it's called. No? So if you have link, you may watch it. If you come immediately to the channel, you will not see it. So don't lose these links. Links are available here, you see. Next, video classes, as I said you, exactly to the subject that we are going to discuss right now. And once again, copy it into your chat. You already have it in your chat. Please find it. If possible, tomorrow, after tomorrow, if YouTube do not restrict me again, I will download it maybe to YouTube. No idea whether it's really have a point, is necessary or not to you. Hope it will be helpful. Well, what these video classes are about, you have seen how I find them. By word error. What we are going to talk? We are going to talk about errors of manufacturing. And let's come back to the channel to find out the research, to find once again your by the word. That is, you also have it. Да? This file and these slides. Actually, it was in parallel with lecture, but I meant another thing to do. I meant to find task to open. Mhm. It's old variant of task. Why I'm trying to open it in order to show you this, please, about assembling. You see that development of directive assembly materials. Ой. Once again, remind you, it's old variant. Maybe you have new one now. I'm just trying to open the things that related to assembly. I think we will even drop now the video. Господи. Так, print screen. I will drop you a piece of it. New you have in intermediate task, intermediate course discipline in mentor. And what we are interested in right now, look, what did I send you already with reminding? What is it? Error of tolerance of unit and error of assembly calculating. Where it's related immediately, pay attention. Item, it's even given here in this item 2.233, calculate the tolerance for outlines. And next, calculate the error of assembling. 234. In that video classes that you have, you might repeat it again. Similar things we were discussing with you also, but maybe not with record in the middle of semester. You may repeat it and you may recollect the sequence of your actions. Let it be what you suppose it to do. In item 233, you do calculation of chains, the jig and jig of aggregate, jig of unit, and you are calculating the difference between them, error of coordination between two jigs. In order you may understand what is supposed to be a tolerance for your unit, because you have unit inside of aggregate. Tolerance, you know, the limits of sizes, you know, only for aggregate, for outer contour of aggregate. You need to understand what is a tolerance for your unit which is inside of aggregate. So you calculate the difference between two jigs. Next, you subordinate to difference, this difference being calculated from tolerance of aggregate, and due to this, you know what is, no, it's described here. Yeah? Calculating this difference, substituting this difference, you see, unit tolerance equal to aggregate tolerance minus error of coordination, difference between two jigs, and you will know what is unit tolerance due to this. Next, 2, 3, 4. Calculate the error of assembling. Calculating of error of assembling, we have studied together with you, and you have even, I trust, photo tracks there. Or somewhere here we will meet at the beginning of class with error calculations. Z1, for instance, да? It's related to explanation about error calculation. that one. Once again, these things, I'm just trying to remind you what you're supposed to remember in order you start calculation of accuracy. And each time, whatever you are working with, either with calculation of tolerance or calculation of accuracy, you are working with so-called technological dimensional chains. With those things, after you have written these chains, everything else became just formal work. You just need to follow these chains in order to calculate everything around, let's say, these chains. And you may say, what is the error of assembling? What is the tolerance for unit? No problem. In case you have these chains, question is where to take these chains. Actually, what these chains are about. Once again, remind you, these chains describe history, but in non-technical explanation, non-scientific like explanation. These chains describe history of object manufacturing and object pre-production, pre-manufacturing. For instance, pay attention to the bottom line, skin. Skin was produced on bending punch. Bending punch was produced from sand mold. Since this place, bending punch and sand mold, it's already history of pre-production. Sand mold was done by templates of cross sections. In turn, they was made from template of contour, recalculated from template of contour. Template of contour we took from control print, and control print actually it's a photo of design loft, and design loft was made from theoretical loft for old-fashioned techniques. For new techniques, I hope you do remember another chains, skin, what okay, at the top, prim. Skin, you see, yeah, was made on bending punch. Bending punch was milled on CNC milling machine controlled by a program, and program was made from 3D model of bending punch, 3D model of bending punch from 3D model of skin, and so on and so forth. It's like history of this object, how it's appeared in metal if we have originally either drawings or 3D models. And the history, what happened, what is next, up to the end, accompanied with so-called values of errors dispersion, where we take these values either in statistics of our enterprise or in reference book, always wherever you take these values, usually in books, as I said you, some of them even written in standards. And normally each enterprise, they have their own corporative standards with their own statistics resolved in such a standard. So the most complex thing, especially for students, is to compose such chains. Once again, remind you that these chains, in order to help you, and not only you, but engineers, even real engineers, but less experienced than those who worked 20 years, 30 years in pre-production, they are also given in books. They are given in special reference books, in manuals. They are so-called typified diagrams of coordination. And here you have heard this magic word, diagram of coordination. Where we take these chains? In diagram of coordination. In your task, I hope I haven't closed it yet. No, didn't close it. Among the graphical materials, you have diagrams of assembling and coordination for tooling and parts. Да? In such a diagram, you will have chains which grows from bottom to the top. Also, we have already talked about those things. And also, you have even the whole video class explanation how we compose such a diagram from pieces, from typified diagram. And two thoughts, let it be, in this diagram. They are about their coordination of parts of assembly unit. If you have panel or if you have rib, whatsoever. On the left, you have order of assembling of this unit. On the right, you have order of jig assembling. 1/3 of this diagram, approximately 1/3. It's about the manufacturing and of jig, what jig consists of, and what was history of its manufacturing. And then we're going to talk right now. No, the previous classes, I hope you already have seen even videos in order to repeat materials. Да? Typified diagrams for rolled parts made of sheet, for stretched parts made of sheet. Why it doesn't work? Because too much files are opened and I see preview normally, but I'm not see ready file. Those things we have already talked about. It's typified diagram for parts. Now we are going to talk about typified diagrams for jigs. I will close this in order to reduce difficulties for computer. Wait a second. Yes, and that one. Whether we need it or not, no, maybe we will need it. Okay, let's stay here. What is it? Why? Let's close it. And that is your task. No, actually we don't need it, so let's close it also. Well, let's come back to the place. I said I will not, do forgive me, I will not explain you in progress. Actually, these diagrams were drawn together with another group practically during the class. And I will explain you only what you already see, like in result. Above the all, to compose the diagram of coordination, first we have divided this sheet onto 7 levels. You see, since bottom, origin of coordination, origin of information, origin of coordination, means of coordination, так? Next, equipment, machines, which we need, technological tooling, elements of interchangeability and coordination, and order of assembling. And pay attention each time. Next, we will talk about assembly jig. Maybe some diagrams are not finished. I do not remember this. Maybe some diagrams we don't need even. We will see it later. Look, to start with, order of assembling. What do we have? Assembly jig. Assembly jig typically consists of some skeleton, carcass, and some locators. Not all the jig has all types of locators. Not all the jig needed. Here it just explained the maximum possible set of locators that you may meet in your bachelor work. Locator of GBH, and you see it here, like jigging plate, it's called. Jigging plate, it's a locator of GBH of flange type. One more locator of GBH, GBH locator of fork type. People, in order you may understand what we are talking right now, you need to come back to junctions subject, what we have studied 2 months ago, let it be. Now, in February, we have studied this subject junction, maybe 2 weeks we were talking about, to recollect what we understand as flange, what we understand of fork or ike type, and what it looks like. I will finish this sentence, and next we will try to see some pictures, maybe. Look, GBH in jigging plate, GBH locator for fork type elements like brackets. Also, you might have locators of CFH, of technological holes, and you may have locators of contour. Locators of contour may be of any type, continuous type, pickups, whatsoever. Actually, here you're supposed also to write clumps, standard items, just to save place and nerves of those who work. We do not write it here, but in bachelor work, better if you add the clumps and standard items. Normally, in your bachelor works, clumps are also standardized, so you may just add here one more rectangle, clumps and standardized elements. Junctions. Давайте, let's see junctions. Ukrainian, да? Junctions. We need class about junction. Опа. Great. Attack. Junctions. Junction and junctions. Madam is... Так. Ну, you see. I hope you will recollect. I hope you see what it comes about. What is it? It's a fork or I type element with GBH, да? Brackets, you see. What we understand as junction, place you have already seen, and what we understand as locator in a jig. You see now this SPA is hanged on locators of fork type junctions. Just in order you may recollect it. Similar things we were talking about when we were talking about the, in order you may imagine what it looks like, the jigs at all. When we were talking about the lab mounting standard and so on. What do we see right now? We see that locators of junctions that we are going to place here, you see they are separate, yes? But they must be on correct distance, they must be on the same axis. How they found this place, these elements of jigs? Elements of jigs, I'm not talking about SPA right now. How they found such a place? They been located by special gauge, you see. Some imitation of wing or imitation of flap, whatsoever you have. This imitation was necessary, this imitator, pretender, it's called gauge of junctions. It was necessary to repeat all the places with very high accuracy. And when you mount in the jig, you attach elements of jig to such a junction. Why we don't call it mounting standard? Because it does not repeat all the aggregate. It does not repeat it in cross sections like this one, for instance. That is what this couple, no? They are not just junctions. To be frank, they are mounting standard because they have both elements of junctions and elements of outlines. You see, they are repeating these outer contours. They are mounting standard. That is the only difference. In both of cases, we are talking about mock-up of our airplane, partial mock-up or the whole mock-up. And this mock-up have ideal variants, let it be imitators, either brackets or contours or whatsoever we need. And when we were talking about flange junctions, let me to remind you about such type junction. It's appeared that it's even worse, especially when it comes about attaching the wing and fuselage, the stabilizer and fuselage, for instance, and especially because of responsibility of these holes, let it be. And it's appeared that jig supposed to be with special element which repeat both holes and flat surface. Usually it's one surface, but this surface realized on good dozen of parts. Here we see photo of stabilizer, and we see that some elements of stabilizer SPA, which actually consist of some different parts, which in contact with this surface, like top cap, bottom cap, web, stiffener, rear SPA, also some parts. This first rivet, root rivet, it's also consists of some elements, and all these elements, they must be aligned into one surface because they all have holes to attaching the stabilizer to the fuselage. What that is the jig of stabilizer as a whole, and jigging plate of stabilizer jig, so special structure which imitate straight surface, flat surface, and has all the holes of GBH that you need. And that is, you see, jigging plate in a jig for SPA already. By the word, it's visible that the whole jig, what it looks like, skeleton, and system of locators and clamps. Да? And I hope you do remember all those pictures you are recollecting, so on. Let's come back to the diagram. Now question is, as I said, how to locate all the elements in proper position with respect to each other. We have jigging plate, we have GBH locator, that one, and all these must be united by skeleton in the system, which next gives us correct results after assembling of little bit the ring in this. It's not mentioned, what is it? No. No? How we may do it? Locate separate pieces in the proper position. Once again, let's come back to your chart somewhere not far from here. I have what? Look at this. I will not switch on it right now. It's only also one of elements of your class. I hope you do remember this explanation, that we may have only two ways. Either we are copying sizes of jig from the carrier of these sizes with yellow color, no, somewhere here. It's shown the element of tooling, either mock-up or gauge. It's way of copying. We place on the skeleton, empty skeleton of jig, we place this mock-up and attach all the elements of jig to this mock-up. Another way is measure positions of elements of jigs. Because they have complex contours, because it's complicated to measure points of complex contour, especially with primitive tools, that was, no, you understand that computers and complex laser devices, they has appeared not 20 years ago, 30 years ago. Not computers appeared 20 years ago, but computer software which working with such things and is coordinate measuring machines which now are portable, like measuring arms and laser trackers, which now are portable but still yet expensive things, extremely expensive, and software for them is expensive, and they require special operators to be trained to work with. 30 years ago, 40 years ago, it was the sort of, I don't know, science fiction, that we may do something like this. And we may measure some elements only either with optical devices or with mechanical devices, like usual rulers. So instead of measuring of complex contours, we were measuring the simple elements of jig. What are simple elements of jig? Holes, certainly. Так, wait a second. Pre-gradient. Where I click it? Oh, fourth and fifth, that we need. Да, about jig manufacturing, I hope you remember. Oh, here is this picture that we just have seen. And it's referring to also to another class in progress that I recommend you to open and watch. That one. Ай-яй-яй. But we need another one. The very last it's called. Little addition. Вот она. Did I copy this one or not? No. Let's copy it to you. And let's copy this to you. Wait a second. Oh, this little addition. What this little addition is about what I just explained to you, that you have variance to do something only. What if you do remember this? How we call it? Mary three-eyed monster, да? The jig. The jig, which consists of continuous locators of upper contour, and locators of CFH. And we are, no, let's say, playing that we need to mount such a jig. How we may mount such a jig? We have only two ways how to do it. It's exactly about bachelor work, particular bachelor work. Either we attaching something, all the elements we are attaching to something, or we measure position of elements of jig, what we might measure, position of mounting holes. Let's come back to the previous scheme. No, why you see two photos? You see the long blackboard in our 203 class. I made photo of the whole blackboard and things divided onto pieces. You see the overlap of these pieces. Well, let's come back to the diagrams that we have seen in this file, and let's compare to what you see in Blackboard. Look, diagram order of assembly jig, skeleton, and some locators, some types of locators that we need. Under each locator, we wrote what we are interested exactly in this locator. Either its contour, like its final locator, or its GBH, or its CFH. What do you see in Telegram right now? Jig, which consists of skeleton, some locators, locator of CFH, locator of them. You may call it by names of parts whatsoever. But how to understand what sort of locator we have? Here we see under locator it's written contour, outline, да? Вот, locator of cap, these top locators, they are locators of line of cargo flow. And outer locator, it's this continuous locator object. It's locator of theoretical outline. It's supposed to be with theoretical outline. And you see this red line that unite all these three locators in one. How they find their proper position? By template of jig. Also, you need to come back. No, you need to come back, but it means that we may lose this place. Okay, we will lose this place entire group. First we will drop it to you, and next we continue switching something. And laboratory class that you have as a very first laboratory class, that one, about assembling the spa by assembly holes and by their remind me. In a jig, yes? Да. No, I just copied you once again, the same that you have already studied. And how we assemble the jig. We had template, flat imitator of outer contours of spa, and CFH of spa. And what we did next? We attached all these elements, whatever, all the locators that we need. We attached locators to the template. Next, we fixed them in this position. And next, we have ready jig. How to describe it in schematic way? How to describe it in schematic way? Look, we have template, and all the locators, they are joined to this template, as you might see. Template and all locators are placed by template. What history of their appearing? It was template, And now all the locators know their place. And what is under the template? It's history of appearing of template, how template was produced. Let's come back once again to this diagram that we have. Here it's not template. Here it's template is two-dimensional element. Here you see mountain standard. Mountain standard, and next you see this complex line which leads to all the elements of jig. That is, it means attached to mountain standard, yeah, and found its place by mountain standard. That means that mountain standard has imitators of all these places. Again, we made with you laboratory class with mountain standard. If necessary, open video and watch again the explanation and what did you see, what you have seen already. Check it again and maybe it will be more understandable for you. Another story, what is under the mountain standard, how mountain standard is appeared. It's all about the methods of coordination, how mountain standard has appeared. You might see we made surface standard first. Next, surface standard, we made negative copy counter standard. Next, it's appeared mountain standard, and mountain standard we are working with energy immediately. Let's see what we have here. Pay attention. What is the difference between these two diagrams? Let's place them one by one in your chart, and maybe it will be more understandable for you. What is the difference? No, I hope it's already obvious for you. Look, the top is the top of diagram. Is it different or not? No, if we're not talking that I forgot to do it here, some lines. Alina, do you see any difference at the top of diagram?
Yes, madam.
You see differences at the top? Assembly jig, skeleton, jigging plate. Do you see differences at the top, above the red line, here and there? Hmm? No or yes? Voice help, please. I see you, Sin, I see Stanley, I see Angelic, and I see Godwin. Do you notice any difference? I mean, significant difference. Maybe amount of elements is different or elements of interchangeability. Look, visible? The top of diagram is the same. These purple lines, is it the same or not? Purple lines, purple blocks.
Same.
The same. No difference. What is different? Look, under the red line, you have quite different rectangles, let it be, no? You have different history of appearing of mountain standard. Mountain standard, according to traditional techniques, which been in use for first 50, 70 years of aviation age. Mountain standard was made immediately from another mock-ups, like surface standard, counter standard, and so on, by molding, like we were talking about in our laboratory work. And those mock-ups in turn, they made by some templates which came from lofts. If necessary, we may open even right now the book about aircraft tooling, book about templates, American books that we used during third year, these historical books already. And now, what we may do now, we may cut such master model, master mockup mounting standard, we may cut it in CNC milling machine controlled by program. And this program is generated from 3D model of assembly tooling, as you might see. So you may have 3D model of tooling. It's include jig and any elements that you need, like this mounting standard or template. It's not detailed here. You see, it didn't say that it's 3D model of assembly jig. It's 3D model of assembly tooling, including tooling of first order, like jig, and tooling of second order, whatever you need in order to mount the jig. Template, standard, gauge, also necessary, and everything must be coordinated. Everything is like all you need are elements of the same 3D model, actually, in the context of assembly. I mean, in software which work with these 3D models, everything is the same. Sorry, frozen a bit because heating system is already switched off for 3 weeks maybe, but weather it's still cold, and time to time just trembling. And what do you see? That mounting standard produced in CNC machine or mounting standard produced by molding from another mockups. That is the difference between two techniques. But what changed in a shop where jig is mounted? Nothing. It was mounting standard. It became mounting standard. Nothing is changing. And all the elements, they are still located. I hope. No, it's opened in the wrong place. Let's open it in proper place. Да. And all the elements, they are just attached to the template object. Now let's try to see. It was, no, as you might see, loft template method, so-called. The new name is also loft template method. And let's see the program template method. Let's compare. What do we see right now? Да? Again, the same principle, attached to. The jig you see here, what like locator of outline, locator of top contour, locator of CFH, without skeleton, of course, you see it. How to, why you see only these elements? Because to remind you that they are important, their position is important, and we trying to understand how to place them in the correct mutual position with respect to each other. By attaching to something. This something is template of jig because it's conditional flat unit. It's very simple. It's no need to do complex mounting standard. You may use only one template for this particular case that we discussed it in our pre-graded class. And what do we have? Look, CNC machine now, да? And this CNC machine made template of jig for us. We are going to use. And this CNC machine, in this case, CNC machine made also locators. The contour of locators, this complex contour, it's appeared. How it's appeared? We made these locators in CNC machine. No, such CFH locators, they are normally standardized. They are just bushings with holes, or pins, if you'd like, or bushings. And they don't need to be manufactured in our plant like separately. We need only to find their position, spatial position. Let's compare this one to what we have seen in yellow, or in yellow picture. The same. CNC machine, do mounting standard, and so on. Seems like from CNC machine must be one more line. No, to be frank, it must be even separate program, if even the same CNC machine. Да? Separate program, maybe separate CNC machine, and one more line to contour locator. In order we may understand that contour locator also has complex contours. It's supposed to be cut in CNC machine. So no difference, as you might see, whether you use mounting standard or you use this, remind me, where is it? Template of Jig. Difference appear only when you change method of coordination. But principle, this attaching or measuring, it's another story. But for each such principle, you may use some different techniques of coordination. What are these different techniques? Remind me. I see. I'm about to cry. Так, let's find one more picture. Here must be. Ой. А, вот они. Мгм. Мгм. Горюшки мои. Смотрите. Мгм. Look, what this consideration, this coping principle and measuring principle. And coping principle, in turn, it's maybe by template and by mockup. Да? Pay attention, what is written here? It's level of what? Say me. Read. Do we have someone brave in class right now? Alena is the bravest out of our boys, I see. Godwin, Yasin, Angelik, Stanley, please.
Yes,
What is
ma'am.
written? What is written here? What's this word? What do you see?
Means
Means, yes, exactly as he said. Alina is the bravest boy in class. Why? The only girl, the only lady that we have, she is the bravest boy in class. How it's happened? Так, now, other brave boys, please don't answer me. Where you see means here, what are means? Visible? What are means, gentlemen? Templates, young talents, mockups, and instrumental means. So when we are talking about the mounting the jig, we're talking whether we use template or mockup, but it's approach of copying of sizes. Or we have instrumental means, its approach of measuring of sizes. And I said you that for each of these cases, you might have differences which determined by techniques of coordination. What four variants you might have? Look at this. Pay attention. Four variants, they are hidden in these four words. You might have drawing, you may have loft, standard, or program. So yes, you have only, like in case of mounting the jig, you have only the choice between either you attaching all the elements of jig to mockup or to template, or you are measuring sizes of jig. But under it, it's also may be hidden variants where these sizes are given, what that you are going to measure. These sizes may be given in a drawing. Then you take usual ruler and you just measuring everything by ruler. These sizes may be written in a program, and it means that whether you have CNC machine that do something in next level, it means how you're going to measure these sizes by CNC machine, or by coordinate measuring machine or by laser tracker in case you have program. Approach is the same instrumental, but means of realization of this approach may be different. Template mockup approach is the same, but history of appearing means of realization of template and mockup in this case, they are different. Either you cut them in CNC machine, or you are also passing the complex complex history of pre-production of this template and mockup. Guys, you make me cry today, as usually. Now, what is changed now? Pay attention. What, with respect to what you have seen here and the, подождите, where 3D model, lofts. Oh, I found lofts. Да. Look, we have theoretical drawings and lofts here, and we have how it's happened, because I'm time to time I'm just changing position of slides and in order to have quick access to some of them. Да? What is changed here? Pay attention. In the first case, which I asked you about, да? Whether has changed something at the top of diagram or not, we understood at last. No, nothing changed. But in this couple of pictures, nothing changed. Now we have another couple of pictures. The same first that we have, like mounting by mounting standard, and one more. Jig is the same. It's still same jig. You see that compound of jig hasn't changed. Assembly jig, skeleton, jigging plate, and you see everything beside of skeleton. By the way, once again, let's come back to this first couple of photos, no, of slides. Everything besides of skeleton was attached to mounting standard. How skeleton was produced? From drawing. You see, tooling drawing at the bottom. But this line is from tooling drawing. Drawing of tooling. Drawing of tooling might appear either from design drawing of unit, or in case of modern techniques, tooling drawing, it was generated from 3D model of assembly tooling, and 3D model of assembly tooling in turn was generated from 3D model of unit. But anyway, skeleton was made by tooling drawing, and to pay attention, no any tooling, no any equipment is necessary, just line without anything at all. Because skeleton is the most rough, the least exact element of jig in this case, and no one interested in any element of coordination in the skeleton of jig. Now we change in approach, people. What does it mean we change in approach? First approach was copying of sizes, and another approach is measuring of sizes. Let's change approach. It was attaching, and now it goes to the measuring. Do pay attention what happened. Scheme became more complicated. This scheme and that one. Да? That one looks practically simple, empty in comparison to this one. Footage with these sub-elements, they are the same. If you compare this diagram and this diagram, everything is the same. The same template of jig, you see. Yeah? But what happened next is disaster, really. No, for most of you. No, not that one. That one. What happened? Let's try to understand. Так, program template method we don't need. We need instrumental method. Coordinate template method. Да. Вот old name coordinate template method that you might find in a book. Вот that one. Да? It's coordinate template method. Now in modern system of classification, it will be called program template method. Why program template method? Because you take what in this orange diagram, because you take program as origin of coordination and template as Господи помилуй, что я имею в виду, дети, не обращайте внимания. Сейчас coordinate template method, it will be called loft instrumental method. Do forgive me, I'm just thinking about, I don't know what about. Loft instrumental method. Why it's called loft instrumental method? Old name is coordinate template method and new one is loft instrumental method. Coordinate template, it was because it comes about measuring the coordinates, and that is why historically this technique has got name coordinate template method. In new system which try to identify everything by system of names, which trying to identify everything according to the origin of coordination and mean of coordination. As origin of coordination, we have loft. As mean of coordination, we have instrumental means for measuring, and it means that it's loft instrumental method. Так, let's see once again. Loft template method. What this coordinate template method, you see it's written under, is loft instrumental in new system of names. And what is changed above the all with respect to this one? Look, previously in line of skeleton logic, it was nothing. It was just related only to drawing of tooling. Do pay attention here. Here is drawing of tooling, and here is a skeleton. But on the way has appeared some additional elements. What these additional elements are. Also, we have laboratory classes. All your laboratory classes, they have immediate relation to those things that we are studying next, that you are trying to implement next into your bachelor work. Oh, look at this. Look at this beauty. What is it? Say me. At least read it here. You see where I'm pointing? Do we have any brave person? What is it? Instrumental?
Stand.
Да. Thank you, Angelica. Instrumental stand. Instrumental stand and another thing that is three-dimensional ruler. And I hope you also have seen video with explanations. Three-dimensional ruler and two-dimensional ruler, which is called loft conductor. Do forgive me, I'm a bit tired already to scroll, and you all also may be tired with this permanent scrolling top and down. So I will not search it, these pictures right now, and will not open the additional books to remind you. But I hope you do remember that is device for measuring the coordinates of mounting holes. In a skeleton of jig, now we preliminary do, no, they are not locators. They are actually something like holders for locators. Intermediate connectors, we call them. Something like brackets with mounting holes. And these brackets, no, in our country, we are usually placing them on the cement just because it's simple and very cheap. In contrary to making joints with screws, bolts, and pins additionally for accuracy. Using the special mounting cement, it's ideal variant in terms of labor input saving and in terms of complexity of work, let it be, and qualification of employee who do this. Да, так вот, once again, where in diagram you see such a thing? What at the very right portion of this explanation, no, this short explanation about jig mounting, you see that we have the beam with these fork-like connectors or I-type connectors, eyeballs. And pay attention with red color, whether on the left, whether on the right, it's mentioned what we are interested in. In case we're using coping technique, really we're interested only in outlines, in these contours. And we are caring only about contour of locators. Now, as we are going to measure position of locators with respect to each other, yes, really we're interested in these contours. But we implement additional measuring bases, these mounting holes. They existed on the left picture, in the left picture, in this approach. They also existed, but we are not interested in their positioning at all. They are just holes for connecting, not more. In this case, on the right, when we have measuring approach, we are interested in them like in additional measuring bases. And this combining of these bases of locators with bases of skeleton of jig must be resulted in creating the whole system of locators, which give grid of locators as a result. And this grid of locators repeating correct outer surface of link. So we are interested in elements which are called mounting holes, and pay attention what is the difference between this scheme and the scheme for coping technique. Look, here in contour locators we have only contour. It's coping technique was mounting standard or template. Only contour and no anything in skeleton object. Now do pay attention to the scheme which use measuring approach. Look, contour locator. What have happened? What do you see here additionally? MH, what is it? Mounting, help me. Don't make me cry. MH is mounting what? Help me. Okay, you made me cry. My keyboard is already really wet. It's already the drop of my tears. The pool of my tears between keys on keyboard. Hole, mounting hole. Why are you afraid to open mouse? You afraid of record or what? People, you are present at all in front of screen? Or maybe your cats are there instead of you?
Here, I am here.
О, да, да,
Yeah,
да.
madam.
Mewing exactly cats, like cats. Meow, I'm here, да? Maybe you just ask someone to sit in front of computer. I don't know. Train it.
Oh, I
Train it.
am listening.
You know, some birds may imitate people voice, yes? Как они называются, попугайчики? I forgot in English. Ну, those. Well. Да. It's easy to... Попугай. Ой. Папуга. Дякую. Parrots, of course. Parrots, да. If you forgot, was it parrot? Попугай. Yes, попугай. You know, those things, да? Those creatures. Some of them quite able to imitate people voices, like this one. Very beautiful, yes? You don't like it?
We
Yeah,
like it, madam.
You like
I
it.
I have someone.
You have small one? Angelic, and usually this small one is sitting in front of you at computer, yes? No? Then answer me, please. When I'm asking the questions, answer me. MH, what does it mean, this MH? What is it? Mounting?
Contour.
Hole, not contour. Hole, mounting hole. Look, in contour locator, we have why we do something in order you may know something. If you do not understand what I'm explaining, then I'm just wasting the time, my time and your time. Contour is this red line. Look, here is the contour. Yeah? And we have holes. We have it in any way we have it. In the left picture, on the right picture, we have it. But in one case, we are interested in position of holes. In another case, we are not interested in position of holes. Here, in technique, we choose mockups, templates. We do not measure position of holes. We don't need it. Actually, these holes are holes intermediate elements, intermediate bases, which we use only to find position of real bases of these contours. Look, what is the difference between these two diagrams? Where we are? Here is. In this case, in diagram of coordination, we are not interested, as I said, we are not interested in the left picture, yeah? Correspond to the left picture. We are not interested in mounting holes. We have in contour locator, in contour locator, we have only contour. In skeleton, we have nothing at all. We are not interested. Now, in contour locator, besides of contour, it's appeared mounting holes, так? And in husband wrote something, and in skeleton also has appeared mounting mounting holes. I'm just closing one by one the messages in order they are not they not appearing. In order they not appeared open in a screen and recorded in front of everyone. And pay attention, in the previous diagram, look at this, template of jig. And there we had, no, mounting standard, yes, no template of jig. Let it be template of jig, doesn't matter. Template of jig here, and nothing else, no any element in equipment. And template of jig here. And additionally, we have some elements of equipment. And the worst, look, here in technological tooling, nothing, no any block at all. Mounting standard is responsible for everything. Mounting standard or template, and it's enough. Great, we have everything already. We just need to attach everything to the mounting standard or to template. Here, people do a lot of tooling, additional tooling, a lot of equipment, additional equipment. Actually, what I wrote here in equipment, to be completely frank, they must be even in means of coordination. We wrote them as equipment, but they must be here in means of coordination because they are means of measuring. Look, this diagram is just stuffed with everything. As only we comes into another technique, another approach, it's appears that we need mounting holes in skeleton, mounting holes in contour locators. We had it before, but in any position actually. Now we need it in exact position and we must measure them. How are we going to measure them? We have instrumental stand to measure position of mounting holes in a skeleton, but we just have seen that mounting holes in a skeleton, where you see the whole skeleton, there is not the whole skeleton, we see one separate beam. How we may measure position of, no, let's recollect what here we have, it's opened. Oh, look, those jigs that we have seen partially, now we see it, the whole picture of this jig. This slide you also have. In Mentor you have it, you have in group those slides with Jigs. So please, if you need, you may open it and take photos if you need. Or that one, look at this jig. Where are the mounting holes? Take this photo. Thinking. Computer is thinking, sorry. Oi. Too sick. We have contour and mounting hole. Here and here. Contour and mounting hole. And pay attention, mounting hole we have in a skeleton and mounting hole we have in the silver-like locator. And all these holes, I will try to do it right now accurately, but I can't promise that it will be accurately, sorry. Color, I don't like any color, actually. One, of course, just as I promised it. I'm not able to do it accurately. One line. All the holes are aligned into one line. Also, such things we were discussing, look, in some different variants. We talking about the same things each time. Where it disappeared. So much things I have copied to you here that it's practically difficult to find anything. What those? Look, how to make the jig, да? How to make this jig if they have separate columns and beams? They have only separate beams, but they need the whole skeleton, this green skeleton. How they assembled from pieces? It's also important. Look, this once again, these elements, they belong, that yellow frame that you see, they might belong to the separate, these mounting holes, to the separate elements. And first problem at all may appear, not in your bachelor work, I hope, because you have not big jig. First problem is how to align element of skeleton with respect to each other, and that you also have studied in your laboratory class. Maybe I will open the book at last. Whew. Because I'm got tired to search pictures. Let's open our manual. It's lectures. Manuals about labs here. Whole computer will stand it yet. So there's another language already. It's lab about mounting standard. I hope you're recollecting. And that is the story that we need. Look. How you may mount the one beam and another beam into correct mutual position. You see now it's shaded, but anyway you see the previous picture of jig. You need to align this bottom beam and upper beam into correct position. There are two ways again. Either you do mock-up, and this mock-up is mock-up of second tooling order. This mock-up name is mounting plate. You do mock-up, something like gauge of mounting holes. And in this gauge, you are going to repeat, like this hole is here, да? This hole is here. If you place this mock-up on one side and on another side of these beams, you may align these beams because this mock-up is stiff. When you attach it to beams from one side, what do you imagine that you place it such mock-up? When you are mounting the jig, that you place it to this side and such a thing on other side, from this side. You already have no opportunity to spoil, let's say, the distance between jig. It was one approach. Another approach that we have seen in the picture. Another approach is with measuring. You see, they are measuring position. Again, they are measuring position of what? Of holes. They added here rulers, lasers, and now they are aligning everything by measuring. When we're using, when we're using this approach, it's less reliable because it depends on people who measure above the all. And that one, it's has less of random mistakes, because once you made this imitator of mounting holes in beams of jig, and next you may assemble this mounting jig, you may assemble this assembly jig with mounting, it's called mounting plate, with mounting plate rather easily, without any additional thinking, and you are guaranteed from making mistakes in this case. Due to mounting plate, you are aligning system of holes of the top beam, of the bottom beam. Maybe you have even 5 beams. If you have jig fuselage, for instance, let's see here. You see that they have more than one beam in such a jig. And no, that is the last photo, in this presentation. You see they have one beam, second beam, third beam, fourth beam, maybe, and in order to align these mounting holes in all the beams, in order to unite all these separate elements, like we have seen just in such photos, there are some separate elements. Either you have mounting plates, or again you must measure something. And how it's reflected in a diagram. Look, the fact that now we changed method of coordination, how it's replaced in diagram. Above the all, in contour locators are appeared mounting holes, and in skeleton are appeared mounting holes. Why only there? Because locators of GBH must be located by, you see it here, gauge of what jigging plate and the GBH locator, they are located by gauge of junctions. Here is, you see, gauge and counter gauge or junction unit. Gauge and counter gauge. Imitator of junction. Where we have seen it today, we have seen it again. Let's come back. No. I didn't copy it to you. Great. Where we have seen it? Junctions. Where we have seen gauge and counter gauge. Oh, sorry. I skipped it. Those things. No, They are mounting standard. Oh, gauge and counter gauge of junction unit. This gauge and counter gauge, it's necessary to attach GPH locator and jigging plate to such a gauge when it's inside of jig. Why we use gauge? Why we not measure it? Because the GPH's accuracy, demands to accuracy are very high, and above the all, because mistake of coordination of these holes will be found out only at the last stage of assembling, when it's already too late. It's the final assembling. When it's already too late to change something, you have some billions of dollars already spoiled, and now it's appears that you need to start since beginning. Да? And techniques of measuring by junctions, they are considered not enough. They are not reliable. This is why in real manufacturing, compulsory all the places with GPH holes, they are located into jigs, and jigs produced, mounted by special gauges, and gauges are coordinated between each other, like gauge of the wing, gauge of the fuselage. They are all coordinated. They are all joined, checked together, that they correctly imitate the junctions of airplane, especially when it comes about hanging of control surfaces, hanging of take-off mechanizations, no, take-off and landing mechanizations, like flap, sleds, and so on. It's too much important that to leave it like for random factors, whether you do mistake or you not do mistake. At the end, in 5 years, when you finalize already manufacturing of airplane, you will know it. And what about jigging plate? Jigging plate, I hope you also do remember. I hope, but my hopes became more and more weak. That when we have flange junction, we have additional kind of tooling. Wait a second, searching. Wait, explain it. Here is one more task to solve to coordinate to couple of married jigs. Yes, we have jigging plate here. Да? Jigging plate, you see, one more example, wing panel. Так, там где-то это у меня было, значит, раньше было. Jigging plate in positions. Center wing model. Jigging plate. Wow. We may find flange junction, tooling of second order. Here is, да, во. Here is its first time mentioned, jigging plate. And how to coordinate two married jigs, for instance, fuselage and wing, да, or fuselage and stabilizer. For this we have one more tooling, master plate. Master plate, or another name in order you remember about this master plate, I even call it mother plate. Look at this. Master plate. Master plate, it's mother plate that's necessary to coordinate couple of jigging plates. One is in your, how it's called, aggregate. No, for instance, you have a rib of the wing, and for wing you have jig of wing. For fuselage you have jig of fuselage. So you have two jigging plates, but they both imitate the same place of junction, wing to the fuselage. In order they are coinciding in holes and surfaces, we do imitator of the junction, master plate, and next master plate, it's necessary to copy it to the left side and to the right side. And this left and right side, respectively, they will B, they will serve as jigging plate in the fuselage jig and in the wing jig. So master plate is somehow imitator also of no, it's some element, let it be, maybe, no, of this gauge of junction. But master plate, it has connection only to the jigging plate. Gauge of junctions, it's already imitator of all their junctions that you have. And gauge of junctions, master plate you need for manufacturing of jigging plate itself. But at the last moment, you compulsory. Так, it's not added here. Let's add it here. Вот так. One more line must be. Compulsory you need this gauge to produce jigging plate. You need master plate. To locate jigging plate and GBH locators in a jig, you need this gauge. In turn, both master plate and this one gauge, they are produced in instrumental stand. Next, skeleton. If it's produced with one piece, that's the whole frame with mounting holes, you don't need mounting plates then. But anyway, skeleton is produced in instrumental stand. In case it's produced by separate pieces and you need mounting plate to assemble, to make the whole structure of the skeleton, not of the jig itself, but only of the skeleton, you use mounting plate. Mounting plate also is produced by means of instrumental stand or loft conductor, depending on how complex this mounting plate is. So you need all those things. You need this one, that one, because of appearing of mounting holes, you see. As only mounting holes has appeared, so you already need all this tooling additional. Oh my. Well, let's stop record, at least for a while. My little birds, as beautiful as you are, my little birds.